Hello and welcome in Welding Workshop. My name is Simon Mark. I'm an instructor in RPI IPS Kigali. Today, we are going to learn about the brazing process. As you know, the brazing is a metal joining process in which a metal can be joined by using a frame produced by a mixing of oxygen and acetylene gases. Then you get oxidizing frame. So today, let us see how you can adjusting our oxidizing frame. Before doing the brazing, we have what we call the brazing load. The brazing load is a load which is used for doing the brazing, which is the copper and zinc, which is a brass. And then we have what we call the flux. There is three types of flux. You have a powder flux, which is this, like this one, is a flux which helps us to facilitate our brazing load to flow easy and to protect the atmospheric contamination from our brazing. So let us start by opening our cylinder valve. Then after adjusting our working pressure, we ignite the oxidizing frame, which is good for brazing. Before you open, we start from the acetylene cylinder. Then after we go to the oxygen cylinder, we do the full open. After opening, the cylinder key must be on the acetylene control, the acetylene valve. Then you become to the control valves. We start from the acetylene control valve. We open the acetylene control valve slowly. Then we adjust by using the adjusting screw or knobs. This is adjusting screw. We adjust your working pressure up to the 0.5 bars. Then we close it. We come to the oxygen cylinder. After opening the cylinder valve, you open the control valve, oxygen control valve, which is the blue color. Then we adjust by using adjusting screw our working pressure. Our working pressure on the oxygen cylinder must be on the just up to 2.5 bars. Then we close it. After we adjusted our working pressure, we become to here to check if our nozzle is in a good condition. Yeah, our nozzle is not in good condition. We have to clean it by using a nozzle cleaner. When you are going to clean, you have to choose a good tip which is a proper to our nozzle tip. Then we insert it inside. We try to crack it. So now our nozzle is well cleaned. After a good cleaning our tip, we open the little bit of acetylene gas. Then we take our spark light, then we ignite our frame. This is the acetylene feeder. We have to add the oxygen gases so that it gets up to the oxyacetylene gas welding process. Our oxidizing frame as we have seen in the previous lesson when we was learn about the oxyacetylene gas welding, we have seen that the oxidizing must be a sharp, the inner cone must be sharp, as you see. Then it's hissing the sound, it has the noise, so that it's become differ from to the neutral frame. So now you can start by blazing. Today we are going to perform our blazing by making a T-joint. When you are going to make a T-joint, it's like this. As you see, you have seen that we have to use our flax, our powder. When you are going to blazing, to perform blazing, you have a blazing rod, then you heat it slowly. Because this one is melting up to the temperature which is below to 415 degrees Celsius, there is no need of heating up to the melting point of the base metal. The base metal only heating, not to heat it up to their melting point. There is no need of melting it, because the blazing is not welding easy, because it's not give us the permanent joint. It give us the temporary joint. It's the reason why it is not a welding. Even if it is used the oxygen and the acetylene gases by performing, but it's not a welding, because it not give us the permanent joint. It give us the temporary joint. So let us perform our blazing. You start by heating up to the plastic state, then we add our blast rod. Our blast rod, we have seen that our blast rod is fused up to the temperature which is below 415 degrees Celsius. After heating, you see this is like a tack weld, but it's a tack weld by using a blast rod. You see, these are our tack weld by using a blast rod. There is no fusion of the base metals. The edges cannot be fused. There is no control of molten metal. Only you have to control our melting of the blast rod. This is our blast rod. You have seen that in order to perform a good blast rod, a good blazing, you have to use our flax powder. Our flax helps us to protect the blazing to the atmospheric contamination. So let us perform. It's very easy, everyone can perform it. If it is not an oxidizing frame, you can get a bad blazing. So you have to adjust very well your frame, because when the frame are not proper and your blazing yes, this is our good frame which we have to use. Yes. This is our final product. You see, this is our final product. This is what we call a blazing. As you see, there is no need of damage our piece, because there is no need of fusion the base metal. This is the difference between the blazing and welding. We have seen that the welding is a process which help us to get a permanent joint. But for us, we did the blazing, which give us a temporary joint. A temporary joint, it means we can separate these pieces, these two pieces, without any damage. As we see, we have seen that the blazing, it's used the heat which is below 450 degrees Celsius. It means when you apply the heat which is above 450 degrees Celsius, we can fuse this brass rod which is fused on this parent metal, then it separates this brazed without any damage of two pieces. So let us try to separate it by using the heat which is above of 400 degrees Celsius. We have seen, you see that when you apply the heat which is above 415, or brass rod which is fused on the base metal, it's removed. Those are the parts of the blast load which is removing. You have to be careful. Thank you. This is our final product. We have seen that we have separated our parent metals by using the frame which has the degrees Celsius, which is above 400 degrees Celsius, which help us to separate our final product by using the brazing. So thank you for attention. See you next.